yes, it's Salah Nasri here, and yes, I have a special announcement. The Game of Chip has just hit 20,000 orders on Amazon. Thank you to everyone who placed the order. The book was just released in December, so I'm very, very grateful and surprised to date. If you are someone who is intrigued, curious about how the semiconductor ecosystem works from beginning to where we are right now, this book was written with you in mind. So order it, read it, and it is pretty much a handbook of the whole ecosystem. In the meantime, enjoy the next episode and don't forget to hit that subscribe button.
1 million, few million. Now we are going to be 100 million units, going to 200. So this is now suddenly iPhone territory.
Now with AI, data centers coming into play, are you sensing it going to be bigger than the iPhone time, or?
Silicon photonics is the only technology that can do it. And it's going to be a foundation on which all semiconductor technologies will be built.
Is it hype? And what needs to happen for it to scale the way the market needs it to?
Our guest today is Amit Shaligram, Director of Marketing and Applications Engineering at STMicroelectronics,
where he owns multi-billion-dollar sales funnels and the company's Tier 1 customer relationships. A Berlin Institute of Technology and Science Pilani engineer with a Wharton MBA, he co-founded a semiconductor startup before crossing over to one of its largest customers.
Today, he sits exactly where silicon photonics collides with the AI data center buildout. Let's dive into why the one limit the whole industry is building around is about to break.
You moved from co-founding a startup into this role at ST. What drove that transition? I mean, what made you decide to go for that?
It is the desire to have impact at scale. I felt that we didn't have the right business opportunity or right investment to really scale that into a multi-$100 million or a $1 billion business. We have to not only work on the current generation of products, but also on what is coming next. By already investing in kind of the N+2 generation of products. So the speed at which AI data centers are moving is incredible, and it keeps me up at night. And once you make that scale-up domain multi-rack, it is very challenging for copper to go beyond a few meters at the 200 gig or the upcoming 400 gigabit per second lane speeds. So I think that is the real opportunity, I would say, for silicon photonics.
With demand will come, of course, challenges. What do you think is going to be the biggest challenges with regards to this scale-up initiative?
Right now, it's kind of a Wild West world, right? So everyone is kind of doing their own thing.
People that I've been speaking to about this have told me that the standardization is an impossible task in the world.
It's not happening today because they are differentiating based on that IP, but that's why you also don't see deployments.
But the power ceiling, everyone fears.
The disruption will cause that threshold to come down. And not many people are paying deep attention to it, in my view.
Hello and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri. And yes, whether you are an industry veteran or someone who's just curious about semiconductor manufacturing, this is your podcast. First of all, I want to say a huge thank you to all the subscribers and all the followers. The numbers in the back end we have had in this year only touching 500,000 views. So thank you for viewing. However, one thing that did pop up was that 3% of you are subscribed to the channel. So do me that favor and hit that subscribe button. Without further ado, today I have Amit Shaligram, who is the Director of Marketing and Applications Engineering at STMicroelectronics. He is leading the regional marketing and applications engineering for ST, where he owns multi-billion-dollar sales funnels and relationships with tier 1 customers. Ladies and gentlemen, Amit, welcome to the show.
Thank you. Happy to be here. Great. It's an exciting time in this industry, and happy to talk to you, Salah, today.
Thank you, Amit. Thank you for making the effort. This is, I mean, you talk about exciting. Nobody expected the silicon photonics convergence to come into play as quick as it does now. I mean, is that something that you're seeing at STMicroelectronics at the moment?
Definitely. I think, like we were speaking before,
Yeah.
I mean, the optical transceivers were 1 million, few million. Now we are going to be 100 million units, going to 200. So this is now suddenly iPhone territory. That is exciting in terms of volume and the scale of deployment.
Yeah. I mean, you remember, ST had such a remarkable inflection point in 2000 and in the 2010 region because of the iPhone. Now with AI, data centers coming into play, are you sensing it going to be bigger than the iPhone time, or what do you think?
It is going to be certainly bigger, no doubt about it, because the overall market is bigger. The overall number of customers that we are targeting with is bigger. And the people that are investing in this data center today on the ground, maybe somewhere else in the future, I think there is no limit, and it is solving real world problems.
For sure. Anna, before we go in a bit deeper in the world of optical connectivity, as one would say, and also, in just the general elements behind AI data centers today, I'm intrigued, first of all, to let the audience know who you are, Amit, first of all. So, of course, we've got the legendary rapid fire round that I'd love to run with you.
Sure.
So, Amit, silicon photonics or silicon germanium BiCMOS, which platform are you more excited about right now?
Silicon photonics, no doubt. I think silicon germanium BiCMOS has its strengths in driving LEO satellite communications, as well as optical, a little bit in automotive. But silicon photonics is transformational today. I think it is changing how the interconnectivity is being deployed. It is reducing the power, allowing increased bandwidth, and more importantly, the scale at which these optical transceivers need to be employed. Silicon photonics is the only technology that can do it. And then what comes next after silicon photonics being used for interconnects? It is going to be transformational for computing, for many other applications, and it's going to be a foundation on which all semiconductor technologies will be built. I think in 15 years, it will be transformational.
Sure. Engineering or marketing, which lens do you trust more when a big decision has to be made?
Engineering, I think, because that's what kind of tells me what is feasible and what we can deliver. I'm working to make marketing the more important lens. Haven't been successful yet. I still rely on engineering.
Fair play. One book every semiconductor leader who has done both a startup or a top semiconductor company should read.
I would say Good to Great by Jim Collins. Great book. But this is a fantastic book, and the concepts in that book of level 5 leadership, or who is on the bus, and more importantly, the hedgehog concept, where the companies have to really figure out what they are best in the world at, what is their passion, and what drives their economic engine. I think that is super important at every phase of a company's journey. So I'd say Good to Great by Jim Collins.
Great book. Big fan. AI data centers, LEO satellites, or automotive, which market keeps you up at night in the best way?
I would say AI data centers. LeoSat and automotive, you can take a minute. You can figure out, okay, this is what I need to do. This is how I need to develop the products. This is my go-to-market strategy. The AI data center, the speed of innovation, the speed at which this demands the next solution is incredible. I think today we have to not only work on the current generation of products, but also on what is coming next, by already investing in kind of the N+2 generation of products. So the speed at which AI data centers are moving is incredible, and it keeps me up at night in a good way.
On your toes. The app on your phone, I was going to say iPhone, on your phone, you couldn't live without.
Currently, I would say Gemini. Well, it changes, maybe Copilot someday, but I think one of the AI apps that are changing how we interact with technology and what you think you can individually do in a day. So I think that's changing fast.
Wharton MBA or BITS Pilani engineering, which shaped your thinking more?
I would say BITS Pilani engineering. It came kind of early in my life. It was kind of foundational. It really made me the person that I am. So I learned a lot, built a lot of friendships and relationships during those years at BITS in the little desert out in India. But yes, I would say BITS Pilani.
In one word, how would your tier one customers describe your style?
Collaborative. I think I'm always trying to find win-win solutions, both for ST and more importantly for customers. I think so. Collaborative would be the word.
Biggest myth about what it takes to bring a first-to-market semiconductor product to customers?
Biggest myth. Innovation is necessary, or maybe innovation is sufficient even for success. I think this is the biggest myth. Semiconductor products, by definition, are not something that end consumers will buy. So it needs to go into a system, and then it becomes useful. So having the ecosystem, I mean, if you talk about a microcontroller, you need to have the firmware ecosystem around it. If you talk about an Ethernet switch, you need to have the language around it. If you talk about an NVIDIA GPU, you need the CUDA software to be around it. So the ecosystem is super important in addition to the product.
If you weren't in semiconductors, what would you be doing?
I think still something in engineering. I kind of like the process of trying to find solutions and maybe optimal solutions. And I think that's more important.
What's one thing co-founding a startup taught you that no corporate role ever could?
I think the importance of all the support functions. So legal, finance, HR, facilities, all the support functions that one would take granted in a big corporation. I think they become super important when you are the startup. So I put together all the servers, installed the Linux, and built the first office in my startup. So I think I would say the importance of the support functions to keep the business, to make the business and keep the business running.
Amit, thank you for the rapid fire discussion. I hope that gives the audience a bit of a flavor of who you are. But let's go a little bit deeper. You've had quite a journey. I've got here in front of me from electrical engineering and economics at BITS Pilani, as you mentioned, to an MBA at Wharton, through R&D and business development, co-founding a semiconductor and EDA startup, and now directing marketing and applications engineering at STMicroelectronics across some of the most dynamic markets in the industry today. Can you give us the 60-second version of how you got in?
I've lived in many different parts of the world. I lived in India, in Singapore, here in California, in Colorado, in Pennsylvania, in Arizona. I think each of these places have been important for me, have offered me kind of new things to learn. I started my career in Singapore, designing cable modem ICs and Ethernet switch ICs for Infineon.
Wow.
Spent a few years there before moving to California as part of an acquisition that Infineon did. Later on, I started my own company, and I think we'll come to that story in a little bit. But in Colorado, and it was from get-go a multinational startup. I think we had an office in India and an office in the US, and we had big dreams. I think we did a couple of pivots. Eventually, after 4 or 5 years, I joined ST, who was the major customer for my startup. I stayed. It was in Phoenix at the time. I ran the R&D team, developing some complex and interesting products. And the past 10 years or so, after my Wharton MBA, I kind of moved to the dark side, if you moved into business development, and now I lead, like you said, a portfolio of product families for marketing and application engineering, and touching a wide variety of end user applications, automotive, LEO satellite, and AI data centers.
Let's go into that. Let's go deeper. So you moved from, which is actually kind of the opposite in my in the executives I get the fortune to rub shoulders with in the interview as well, is that normally they work for very large companies, MNCs as you, and then they go and do a startup. So you went from the opposite side into where you were at Infineon, and then you did the startup, and now at a large company. So it's interesting to kind of identify that you moved from co-founding a startup into this role at ST. What drove that transition? I mean, what made you decide to go for that?
I think it is the desire to have impact at scale. When in my startup journey, so the company that I co-founded, it's still around. My business partners still run the company. It is a very successful business. For me, what I wanted to achieve was a wider impact. And in my context of the startup at the time, I felt that we didn't have the right business opportunity or right investment to really scale that into a $multi-$100 million or a $1 billion business. So for me, moving from that startup world into ST was really about, the transition was about scale, to try and find opportunities where the impact can be larger than what I could have in that particular startup.
Nice. One key thing I'd love to understand is that from your side of things now, you're dealing with multi-billion-dollar sales funnels now, and relationships with tier one customers. What does it actually mean to manage that scale? You mentioned that specific, even like now, I mean, we are going to dig into the Silicon Photonics initiative that you guys are working on. But, how do you keep the engineering and commercial sides of the organization aligned with the pressure that is on?
I think it's somewhat simple in a sense. The North Star is meeting the customer requirements and meeting the customer expectations. So I think we operate with this. If you operate with this philosophy, then the details of what is commercial or what is technical, they kind of start to merge and kind of converge, because in the end, they're trying to meet a customer requirement or a customer expectation. I think that is how you keep things aligned, by relying on the common goal of everybody, whether you're on the technical side or on the commercial side, to address the customer needs. I think that's how I think about it.
So you're actively shaping next generation platforms at ST. As mentioned in the silicon photonics and silicon germanium BiCMOS processes. from early business case through ecosystem development and customer adoption. What makes those platforms the right bets, you would say, for the market that you're serving, and what does the ecosystem development challenge actually look like?
Definitely silicon germanium, BiCMOS, silicon photonics, and also our microcontrollers and other standard products like E-square prom. These are the building blocks of optical transceivers, of all connectivity in data centers. And these are the platforms today are available at the right scale, at the right performance, at the right energy consumption to really enable the development of these optical transceivers. So if you take the example of silicon photonics, I think the platform built on the 300 millimeter wafer size and built as part of a large fab where we have the ability to allocate capacity as customer requirements change. I think this is fundamentally super important for adoption of this technology and for the continuous scaling of AI and data centers.
I think it would be important for the audience to understand is that one of the unique things is you don't need indium phosphide perspective wafers, or with the work that you guys are doing, it's a differentiator, I believe.
If you look at a system level, like an optical transceiver, always requires a light source. And that light source is typically based on indium phosphide. But if you integrate all the other optical functions of that transceiver on a 12-inch silicon photonics wafer, you don't need as much indium phosphide material. So you can, as an industry, we can optimize overall the use of indium phosphide or silicon photonics, or maybe there are also other materials in play to address this demand that we see today. But yeah, you still need indium phosphide, maybe in different quantities.
I see. So what makes STMicroelectronics silicon photonics so unique in comparison to the rest out of there? So quite a competitive market these days, as one would say.
Yes, I think what is differentiated in this technology is that it is built to address specific customer requirements. It is built to address the needs that big end customers have, not just in terms of single device performance, but in terms of higher yield and throughput and scale that they need. So we do have the building blocks, if you will, the modulator with the photodiode, as with the right level of performance to address the data rate that is needed. But one thing that is unique is the efficiency of the coupling scheme. So a weakness in any optical platform is the connection between the fiber and silicon. So we have really optimized the connectivity, this edge coupling solution that is included in the ST platform. It's we believe the lowest loss edge coupling solution, and really has overall impact on the system performance when you integrate that fiber with silicon.
I see. This is really interesting now, and I want to go a little bit more deeper, if you may, Amit, on that perspective. Let's say from a perspective whereby you're looking at this as a holistic approach, right? And looking at where once upon a time ST was on time with regards to the inflection point, right, for the iPhones. Can you share with us the preparation for silicon photonics? Because you guys were a little bit more earlier in the game. and now you're back into it because of the demand. Could you share more about what happened, how it happened, what was done from a strategic standpoint of view?
I wasn't as actively involved in the earlier incarnation, if you will, of silicon photonics at ST, but I've been deeply involved in the current development, if you will. And what I can say, we keep the heritage of what was done before. The fact that we were shipping thousands of wafers many years ago in silicon photonics. We keep that heritage. We keep the R&D know-how of that platform, and we architected this platform with the scalability in mind. It's kind of learning from what we did before to kind of address the higher data rate, higher capacity needs that we have in the market today. So I think it's a very customer driven approach of developing this platform in partnership with all the big players in the industry today.
That's it. I'm also intrigued to also understand from your side of things, like in terms of the patenting element, like how many patents does ST go through on a daily basis? Is it a daily thing? Is it
It's quite a few. I think the innovation is really the DNA of the company. So I think the two things that I would say for ST, one is we are very innovation oriented, and the second is we are very customer oriented. So this unique combination of innovation at scale and customer intimacy, I think, is unique in the industry. So yes, we do file a lot of patents across many different spheres in many different technologies. But I think the ability to take those patents and solve real world customer problems is what differentiates ST.
Sure. So you, of course, look, you're working across AI data center connectivities, LEO satellite communications, as you mentioned, and automotive. I mean, those are very different markets between each other. And they both, all of those have different buying cycles and requirements. When you're talking to a tier one customer in any one of them, how do you frame ST's value?
Yeah, like I said, so first of all, in these markets are different. The buying cycles are different. But if you look at what is needed in each market, so in satellite communication, it's the RF performance or the radiation tolerance. If you look at the automotive, it's kind of the sensing and the actuating or the power control. And if you look at the AI data centers, is optimized power and connectivity. So what is common across all these different technologies is all these different applications is pure CMOS performance or digital density of a 2 nanometer is not necessarily enough to address these applications. So they need technologies and solutions that are beyond the raw CMOS performance of an advanced FinFET node. And that is kind of, I think, the common theme that makes ST, that gives ST the unique play or unique value proposition to address these markets. So each of these markets require technologies that address the specific need and enable integration of, let's say, digital performance with analog sensing or connectivity or at the right level of reliability. So that's really the value proposition of ST. So as IDM, we can do system technology co-optimization by developing solutions that customers need, and we kind of control the manufacturing, which is mainly in-house. that's really the unique value proposition. What is also common now that I think of it, for all these markets that we talked about, they are they're driven by few key end customers. If you think of automotive, if you think of space, if you think of AI data centers, the number of customers that are driving the scale and innovation in these markets are a handful. And that's kind of another strength of ST to work closely with a limited set of customers. So we have the technology and, like I said, the customer intimacy to solve real world problems.
Thank you, Amit. I mean, one key thing is the semiconductor industry has been going up in different cycles, right? And I'm not talking about the stock price only. What I'm trying to get is that basically, how are you? I mean, ST's been in the game for a while. It's seen it all, up, down, up, down. How are you thinking about this and the customer strategy across your portfolio in this environment? And where is ST aggressively now?
Yeah, so semiconductor industry definitely is cyclical because it takes time to develop a fab or add capacity to develop a hardware solution. The speed with which the end applications move, like the interest in EVs or the rise of AI, they may move faster than you can build a fab and add a capacity. So certainly, semiconductor industry is cyclical. But I think the way kind of we think about it is to look at longer term trends. I think we are here for the long haul to kind of invest in platforms and technologies and partner with customers that have the scale, that have the needs, that if we develop platforms and solutions, they are going to be across the semiconductor cycles. And I think we also have the ability to deploy a solution developed for one application into another. And I think that's also because we have so many different technologies, it gives us that ability.
It's very important that, look, you're working in the intersection, as you mentioned, of AI data centers. You have the LEO, SAC, communications, and automotive. These three markets, at the end of the day, are all experiencing different type of growth, right? But from your perspective, what do they have in common from a semiconductor perspective? And where does ST's technology have the clearest edge from the three that you're working with?
I think automotive has been kind of a long-term strategy, and we have developed products and solutions in automotive for a while. Space is being also kind of a newer space, but still for a few years we have had good traction in the market. The new and intense activity now is on AI and data centers. I think this is where, like we talked before, silicon germanium, BiCMOS, silicon photonics, and the STM32 microcontroller, and the E2PROM, and the power solutions for both AC to DC and DC to DC. So these are kind of the areas where we are really doubling down, and we have differentiated technologies to address this AI data center market for sure.
On the LEO SAT constellations, which are being built at scale that was maybe unimaginable 5 years ago, right? What does that demand look like now for you guys, and how are you thinking about the roadmap for silicon germanium BiCMOS in that context?
So silicon germanium BiCMOS is kind of the workhorse of the RF world. So it really has the bipolar transistor with the combination of CMOS. So this is a platform that has a MOS transistor as well as a bipolar transistor on the same wafer. This is really the workhorse for excellent RF performance. So when you develop the front-end ICs that are on the satellite side or on the user terminal, the this transistor really makes that communication most efficient. So there is definitely continued growth for SiGe BiCMOS in this LEO-SAT world, but with the interest of developing data centers in space and some other innovative applications from space, I think there will be a convergence of what we are developing on the ground for automotive or AI data centers to be used also in space. So I think there is a convergence coming of many technologies that have been developed in ground and its application in space, for sure.
I need to ask you about the risks behind silicon photonics in terms of, I mean, if you look at it, the increasing focus, which is central to AI data center connectivity, and as the bandwidth demands of large scale inference become kind of impossible now in comparison to the use of copper, right? How do you think of that technology or where it is right now in the adoption curve? Is it hype? And what needs to happen for it to scale the way the market needs it to be?
And if you think about where optics in general and silicon photonics in particular, because there are other optical technologies than silicon photonics, there's EMLs and VCSELs. But if you think of kind of the optical solutions today, they are really in what is called the scale out part of the network. So this is rack to rack connectivity. So this is where the optics is mostly used, and all the optical transceivers that we talk about are being deployed for rack to rack scale out connectivity. If you look at what is inside the rack, it is still copper today, and the bandwidth inside the rack is 10 times the bandwidth outside the rack. So the scale up domain today is at a rack level, and this scale up domain, once you get to the next generation, there is a need for this scale up domain to be multi-rack. And once you make that scale up domain multi-rack, it is very challenging for copper to go beyond a few meters at the 200 gig or the upcoming 400 gigabit per second lane speeds. So I think that is the real opportunity, I would say, for silicon photonics. There are also some other competing technologies that are wanting to make a play, but silicon photonics is mainstream. So today it is in scale out and seeing this big growth, when there is a 10 times bigger port which is inside the rack connectivity that will migrate to optics, or we expect it to migrate to optics. So I think for the next several years the demand is going to be really strong in my personal opinion.
With demand will come, of course, challenges. What do you think is going to be the biggest challenges with regards to this scale-up initiative?
I think right now it's kind of a wild west world, right? So there is everyone is kind of doing their own thing. There was some movement at OFC recently where there were a number of standardization initiatives announced at the for the dense pluggable, which is called the XPO, or the near package optics, that is called the Open CPX, or even on the co-package optics where there's an OCI MSA. So there is a movement towards standardization that will help not have not have resources that are going into development of unique solutions just for the sake of them being unique. I think this standardization will really help with the scalability.
Yeah, but a lot of people that I've been speaking to about this say have told me that the standardization is an impossible task in the world, or specifically, I'm talking about co-package optics here.
Yeah. But I think at least we kind of create a path for people to develop solutions and direct resources towards kind of a common end. So you kind of have to define what is differentiation and what is kind of common for solutions to talk to each other, right? So as long as you standardize the connectivity, then you can still differentiate within your product. And I think, at least my opinion, having this movement towards standardization is going to accelerate the adoption of each of these technologies.
If that was the case, then why are people not doing it now?
They are. I mean, they are in the sense of in the pluggable world, it is all standardized.
Co-package optics?
Co-package optics, I think people are now moving, in my opinion, to not fight the battles of which modulator is better, but rather what should be the data rate in the fiber so the GPU can talk to the switch. I think it doesn't matter what's your modulator inside, as long as you can bring out whether it's a Mach-Zehnder or a ring modulator, but if you are as long as you're sending 4 colors across the fiber, and that is common, then you can still innovate inside your silicon or in your circuits. It's not happening today because they are differentiating based on that that IP, or that not necessarily at the system level. But that's why you also don't see deployments. Okay, so that's kind of the flip side of it.
That's a very good point. Wouldn't it be more realistic to have some guidelines in place rather than standardization?
Possibly, but I mean, in the end, standardization means that you can be interoperable. Guidelines don't give you that. So I think having interoperability is going to be important. I mean, that's why you see the growth of pluggable market, because there is standardization and there is interoperability, and that comes to the NPO and eventually maybe to CPU. I think that's where you will see the big adoption, in my view.
And how does that help?
What do you mean?
The initiatives from a standardization. I mean, sure, people are looking at differentiators, using different cases in place, set rulings, metrics.
But I mean, if you look at the NPO MSA or the standardization now, what it is defining is the socket, the physical dimension, and how the connection will be, what will be kind of the bump map and what will be the connection. I think these are things that people decide for themselves, and they make a choice to do A versus B, not necessarily because B is better than A. It is they have to pick between the two, right? So if that is standardized, people will always pick, okay, this is the bump map to which we have to design to. So now it reduces the effort that you need to do to develop the overall solution. Your solution development becomes faster, and then end customers will have multiple options to put in that same physical socket once it is standardized.
There's a good way of explaining it. I appreciate it. let's go into the personal insights and career wisdom side from your side, Amit. I mean, looking at your career, what would you say has been the most difficult decision that you've had to take?
Couple of times I've had to downsize the teams, close offices even, and that's difficult knowing that it's much harder on the other side of the table. I think those have been a few difficult decisions for me. I think as leaders we have to strive to minimize the occurrences. So as we make decisions towards scaling, towards investing, to keep in mind the people side of the equation. And when it does happen, because it cannot be right all the time, when things do not go to plan, be respectful, be empathetic, be transparent with the people that have been impacted. And I think that's kind of the learning for me.
And what's the most proudest moment?
The proudest moment, I think probably not one moment, but I would say the overall gamut of relationships that I have built, both in the professional as well as personal world. There are a lot of my colleagues who I consider friends, and I think having built those relationships over the years that's what kind of makes me be proud, if you will.
If you could point to one transformative shift coming into the semiconductor markets you work in over the next decade, something that most people aren't fully paying attention to yet, what would it be?
I think like today there is a notion that power is the limiting factor for AI data center growth.
Right.
And there are curves that people show that power consumption by data centers by the end of the decade will be this percent, and it's kind of on an unsustainable path. My sense is that there will be disruptive technologies. I'm sure there are people working on it now, but I do believe there would be disruptive technologies that will change all the three vectors of this data center. So the power delivery, the sources of power, there are disruptive technologies there. The compute, the way it is done today, there are disruptive technologies today that may come. I think we talked about photonic computing or quantum computing as an example. And on connectivity side, I think there will be different materials, different sources that will solutions that will come into play. And I believe that power limit will no longer be a limit. I think the disruption will cause that threshold to come down, and not many people are paying deep attention to it, in my view.
Absolutely. And when you talk about power, are you referring to the wide bandgap technologies being the solution?
I'm not an expert in power technologies, but that could be one of the solutions.
Last question, and of course it's a big one, is what legacy do you hope to leave, Amit, as an engineer, an entrepreneur, a commercial leader, and someone who has spent 2 decades helping the semiconductor industry find products and platforms the world actually needs?
Actually, if I think about all the products, all the technologies that I have had a good fortune to work on, they have always been about moving data and making connections. So from my first chip that was a cable modem, I see on Ethernet switch to data center connectivity or satellite connectivity or sensing in automotive. There's always been about making connections. So I hope these connections make the world a smaller place.
Yeah.
Uh,
Interconnected.
it's interconnected world. So and for the better. I think the distances uh, are reduced in the world now because of the information flow. There are, of course, some negative aspects of it, but on the balance, I hope that the movement of data that is enabled by technology that I have had a chance to work on for the past couple of decades and maybe some more time
Yes.
in future make the world a better place.
That's impact. That's your northern stuff. Amit, is there anything you want to tell the audience? Any last comments that you have? Or
Um, I think I mean I would say that even though we kind of talk about technology, we talk about uh, AI. In the end, it is always about people. It's always about relationships and people. So I think we should all keep that.
keep that mode. Yeah, that's what makes our industry special, right? It's an industry whereby the people we're around, it's not a short-term business. It's a long-term business. And, the average is, 30 years, it looks like, which is the average. And it's not easy to leave this. I've never seen an industry, Amit, whereby you have these guys who come in, they start a new startup, they sell the startup for hundreds of millions or billions. And then a year after, they're back in doing another startup. I haven't seen many industries that do it like our industry. And it must be the community. It must be the people.
Yeah,
Purpose.
yeah, and it's the
Important.
and it's the impact that we can have, right? I mean, if you think of any inanimate object in this world, and if you have to make it a little bit smart or a lot of smart, the only way you can do it is by adding chips into it. I think that's the only way. There's maybe biology is an exception a little bit, but I think outside of that, if you have to make anything slightly smarter, you need electronics, you need chips.
That's a valid point. Amit, thank you for joining us on the Semiconductor Leadership Podcast. It's absolute pleasure to have you here. Ladies and gentlemen, thank you for joining us on the Semiconductor Leadership Podcast. If you want to connect with Amit, you can connect with him right here. His LinkedIn profile will pop up and you can reach out to him. And also, if you want to check out STMicroelectronics and what they're up to in the game, just Google them, STMicroelectronics. Very easy to do that. But other than that, they say it takes a village to raise a chip. So it's going to take a village to raise this podcast. So hit that subscribe button. If you enjoyed the episode, please like, share, comment. And if there's anything that's interesting that you found that you would like to have further discussions, you can reach out to Amit directly via LinkedIn. So yeah, thank you for joining us. And I look forward to seeing you at the next episode. Take care and bye for now.